everything that we have talked about. Now we are just trying to put everything in under a urban architecture. That is our case study. Like, as we all know that there is a lot of traffic at the intersection, so we are applying the principle of SDN at the intersection. So first we're going to talk about like how vehicle to vehicle communicate between in an urban setting. So let's say if you have three vehicles, so we can either use cellular networks or we can use the VNets. If we use the VNets, the latency is going to be less if the number of vehicles is less than three. But if the number of vehicles are more than three, we are going to use the cellular networks because of the latency issue, and it's not that reliable, the VNets, if the vehicles are more. Then we have vehicles to RSU. So what is RSU? The RSU is roadside units. So what they do is they're gonna get the condition of the roads, and when the vehicles are gonna demand that, they're gonna send it to the vehicles, all the information, and the drivers can use the information. Like if there is construction going on, the roadside units can tell the vehicles, and the drivers can be cautious about those constructions. After that, we have roadside units to MAC. So all the information that we got, we can send it to the MAC. That is mobile edge computing. So every information will be sent to the MAC. MAC is at the base stations, and the base station is still going to send to the vehicles, basically, instead of the cloud server, which is going to take more time, and it's going to reduce the latency. And after that, we have vehicle to MAC. The same thing going on, like vehicles are collecting the data, or MAC is sending the same data MAC is processing the data and sending to the vehicles, and vehicles can use those data to their advantage. And then vehicles to base station. So base station is doing a lot of stuff here because we have MAC at the base station. So the base station is, if there is any data forwarding failure, the base station is gonna take care of that. The base station is gonna offload everything to the MAC or to the cloud if we don't have the MAC. So base station is really important in this architecture. After that, we have MAC and cloud servers. Like MAC is a temporary, it's like a cache in your computer, and cloud server is a permanent space like your hard disk. So MAC is gonna keep the important stuff inside itself, and gonna send the stuff that is not important to the cloud servers, because Mac does not have that much memory in it. So Mac has to rely on cloud servers to process something, but it's not gonna happen every time. Like the applications that are not delay sensitive, we can send it to the cloud servers instead of keeping it at the Mac and using the memory of the Mac. After that, these are the results we got from after applying all this SDN stuff at the intersection. As you can see, there are 5 vehicles, 25, 50, and 100 vehicles, and the latency is calculated in time. So as you can see, for collision for cooperating collision system, the latency remains the same for all the vehicles. It does not really depend on the vehicles. But if you see bird eye, the bird eye is also almost the same, but for 100 vehicles, because it's congestion, like there are a lot of vehicles inside it. So for bird eye system, it increases a bit for 100 vehicles. Like it takes a lot more time, so latency does increase for that. And then we have the intelligent navigation system. It's almost the same for all of them. And after that, we have reliability. Same like latency, reliability also remains the same for all the vehicles. It does not really depend on how many vehicles we have in an area. It can be 5, 25, 50, or 100. Same with all of them, but there is a bit increase when there are 100 vehicles for the two applications, like for the board view and for the navigation system. They need some bit more reliability. And then the data rate, as we all know, these applications, the bird view application, need more data. I hope you all know what bird view application is. It's like a camera in a car that you can see at the back. It gives you a bird view of the vehicle. Like you can put it at the top of the car. You can see at the back of the car. It's mostly used by the old people. Then we. Then we have to discuss it, like why do we want to use SDN? Why do we are not using Vanets? What is the problem with that? scalability. Scalability is the issue that comes with SDN. As it uses protocol agnostic. So what do you mean by protocol agnostic? Protocol agnostic is like, it's not specific, like the hardware is not specific. You can bring in new hardware, you can put in new hardware, it's not reliable on some specific hardware. So you can increase the scalability of the network by doing so. Then we have controller upgrade and management. As the SDN controller is basically installed on the basic software, basic computers. So the update of that is really easy. That's why I also use SDN networks. And now the main thing is like, because we are taking out the control plane from the routers, if we can say it, and we have a separate section for that. So the networking is really easy. You can do it with a click of a button. It will be done, which we cannot do it with Vanets. After that, we have Mac clouds. As you know, that latency issue can be solved by Mac because it's near the base station. So Mac can take care of the delay sensitive applications. Yeah, we're going to talk about after that. Although there are many advantages of this, but there are some issues that we have to face with SDN too, like seamless handover. You can see a car here, V8, is going from here to here, like it's changing the network. Now, what kind of problem it can face? Like the first problem is, as he talked about the flow table or flow chart, open flow, it has some tables. So when we move from one network to another, it has to be updated. So that is one problem because they are moving at a very fast speed, the vehicles. So we have to really update them at really fast speed to give the drivers an edge. And same with the direction services. Every service that the previous network was providing, the new network should be able to provide. As far as the car enters the new network, it should be really fast. And one more thing, let's say you were in the first network and you were watching a 4K video. Now you suddenly jump into a new network.
Not me.
Chuck.
My kids.
Yeah.
In the back.
Yeah, old people does not really go with 4K.
My kids in the back.
Yeah, some of them are.
I cannot go.
Some of you might be using a 4K video and suddenly you are in a new network. So the bandwidth requirements are not that good. Like the bandwidth provided by the new network is not that good. So it could be a problem. You might face a buffer of some seconds. It could be much higher depending on the network. Then we have network partition. Like if it's a stationary network, we can divide it into different SDN controllers. But as the vehicles are moving, it's very difficult to do that. So this is also a problem. Then they have to find a way for that too. Let's say you are in some place where there is no base station. What are you going to do? You cannot rely on the controller. You still have to have something to communicate with the other vehicles that are around you to get the information. So what you can do is you can have the Vanets as well as the SDN controller technology both combined within your car. You can do that, but it's going to increase the cost, so it's not that good. But they are also looking forward to deal with that. So this is the conclusion. As we all know, this provide better data rates, scalability, network configuration, forward policy can be updated really fast because we have taken out the control plane out of the data plane. And Mac, as you all know, Mac can provide really many advantages of the latency, can improve in latency and all. So with that, we conclude our presentation. I hope you like it.
You know how ABC can help for the handover?
Yeah, it can help, but I have an idea.
But the paper doesn't talk about it?
Paper doesn't really give an overview of that. It just talk about how Mac can solve the problem of latency.
Yeah, that's...
It does not really go into how it can help in the handover. But I guess because it's near the base station, so as it's near the base station, when you're moving from one network to another network, there will be more base stations. So the Mac can keep the information with itself, and because it's near, so latency will be less. Like you are sending something to the base station, the base station can really send it to the Mac, and Mac really process it really fast to help you out with that. But still, it's kind
Are you
of
familiar a little bit with Vanets?
Or sir, it can.
no, I'm
Is this your first contact with Vanets?
no, like
Are you familiar with Vanets?
yeah, I am.
You
With
know how
Vanets,
the handover is done?
with Vanets, what we do is like if we have two vehicles, we use ad hoc technology.
Yeah.
They don't really use the other way of dealing with it.
There are so many messages that are exchanged,
Mhm.
right? That's the only way to do it, can do the handover. But they have the MEC. MEC with the,
With
then they
SDN.
have global view.
Mhm.
So do you know how many, you know when the vehicle is moving from one network to another, one base station to another?
Mhm.
Do you,
With Vanets,
yeah? So all the communication before the handover will be done with MEC. Now we can,
all right.
think about it. Are you, Dinesh?
Yeah.
I'll talk to you. Thank you. Have a good.